Imagine you're a fearless explorer standing at the edge of a mirror. On one side is your familiar world. On the other, a place where shapes twist and look in ways you can't yet describe. What if that mirror led you straight into the heart of topology, where the line between donut and coffee mug vanishes, where a loop can slip through itself without ever tearing? What if you took an ordinary bundle of paper and gave it a cunning half twist before taping the ends together? Suddenly, it becomes a Möbius strip, a one-sided world where an ant can walk forever without ever crossing an edge. Now picture cutting the band down the center. Will it split in two? Nope, it morphs into a longer loop with two twists. What if you kept twisting, folding, and slicing? Each cut reveals a fresh surprise, a new genus, a new gateway into higher dimensions. What if you could step off our three-dimensional stage and wander inside a four-dimensional torus? In our world, the donut has a hole you can see. In 4 dimensions, there are holes we can't even picture, holes within holes, stacked like cosmic matryoshka doll. You could glide through one hole and emerge from another without ever turning around. What if you tied 2 such tori together? You'd create a double torus, like a snowman made of donut. Suddenly, your map of space changes. Loops that once seemed impossible become trivial, and trivial loops become impossible. Every path you trace carries a hidden story. Which hall it loops through, how many times, and in what order? What if this wasn't just playful paper folding, but the secret code of our universe? In knot theory, every knot you tie in string has a distinct fingerprint, a fundamental group. Scientists whisper that these topological fingerprints could encode quantum information. What if a quantum computer used knotty particles to store bits? Each twist and weave would protect data from outside noise, making quantum computing as reliable as your morning thought. What if you could classify every smooth shape in 7 dimensions? Exotic spheres lurk up there, spheres that look ordinary from afar, but hide wild twists within. In 1956, mathematicians discovered that not all spheres are created equal. Some spheres are like identical twins with a tiny hidden scar. You might call them fake, but they hold keys to cutting-edge geometry, string theory, and even the shape of our cosmos. What if, by studying these strange new worlds, you could rewrite physics rulebook? What if the next breakthrough in material science or cryptography depends on your ability to think like a topologist? Close your eyes and imagine yourself drawing loops on surfaces that behave like alien membranes. Follow those loops, one twist at a time, and you'll find portals to unseen land. So pick up a strip of paper, twist it, slice it, knot it. Let your curiosity pull you through the mirror. Topology isn't just shapes. It's a grand adventure in thought. And the moment you dive in, you realize that the universe itself might just be one giant, beautiful and impossible knot.